Building a prototype helps everyone involved in the process understand how all the pieces and parts have to come together. And it's certainly a wonderful thing for the Center for Architecture because we've never done anything like this before. And I think it's going to stimulate a lot of creative thinking to fabricate curtain walls for the future. Plus, we wanted it to be a learning experience for young people. I went to Brooklyn Technical High School, and I think it's important that young people have the advantage of seeing something built full scale. The innovation of this curtain wall is bringing many things together that haven't been brought together before. And here we are today getting ready to install it and see how it works.
So the term curtain wall refers to essentially an exterior wall of a building that is non-structural. The liquid wall is different from standard curtain walls in the aspect of its fabrication. It's a cast frame which is being used in place of what is typically either aluminum or steel structural profiles. The liquid wall concept is really based on three ideas. The first is the liquid form of the concrete itself. The second is, in this particular prototype that we're doing now, the form of the wall panel was designed according to its structural needs, which results in this kind of wave form in the panel itself. The third element of the liquid wall concept is that there is a passive solar collector panel in the wall into which liquid is actually flowing to recover heat from the sunlight on the building.
Ductile concrete is an ultra-high performance concrete that provides ductility, durability, strength, and aesthetic design flexibility. It actually provides architects and engineers the ability to have thin, complex curvatures, longer spans, with products that basically are going to last much, much longer than regular concretes do. So it's a wonderful opportunity for them to design in a way that they've never kind of experienced before or been able to work with before.
The first step in the process is done by the architects and engineers. We've designed a digital model of the liquid wall panel. That model is then used for a CNC milling process where a machine reading the digital model cuts the positive form out of expanded polystyrene, creating a positive from which the negative rubber molds are built, and those rubber molds are used for the concrete casting process.
The rubber allows us to have a little more flexibility and a better finish for this particular project. So the rubber was set into the form, and then once the positive was stripped out, we reversed the process, so now we can cast directly against the rubber. And the rubber, like I said, will give us the best finish, also allowing the flexibility to strip this complex shape out of the mold. And we see a value in taking the concrete to the next level, giving us higher strengths while reducing the weight.
When you start out doing a prototype like this, it's not different than doing it on a new building. Even though this was going to be a section of wall that could be used at the exhibit, you had to go through the same process. Get around a table, meet with the architect, meet with the engineer, understand what the challenges were, how the design was going to ultimately be fabricated in the shop, bring in the manufacturer, the entire team to see how this would go together. And then when you finally understand what you're up against, the challenge to get it inside of an existing building was not easy. It was, how do you do it cost effectively? How do you do it safely? And how do you do it in a way that it could not disrupt the activities of the center? And the contractor, Competition Metals, came up with the idea of not having to remove the exterior storefront, but to remove some interior glass, bring in a hoisting beam, create a scaffold with a lift, and come up with a way in terms of how to make this happen. And that to me is really what makes these projects so exciting. And I think that if this exhibit could somehow demonstrate how the different disciplines work together to come up with a building, and the opportunities in terms of design and constructability are limitless. I really look forward to seeing what buildings are going to look like about mid-21st century, 2050, mark my words. We'll be seeing some buildings the likes of which we've never seen before. And let's hope that we could inspire some of the younger designers, current designers, and older designers to keep doing what they're doing.